Hi, welcome to Chemistry edition of Darling Fee's channel. My name is X-Coco and I am excited to present to you ways of calculating oxidation numbers using a simple trick. This trick is very helpful. It has been used in various compounds and it really works. Please do this for me. Kindly subscribe to this channel for more of our presentation. I hope you are ready. But before we start actual calculation, there is something I want to give you. That is the periodic table. Now looking at this periodic table, this is for only the first 20 elements. I just want to remind you that with the periodic table, we have group 1 to group 8 with their charges. So group 1 has a charge of +1, group 2 charge of +2, group 3 +3, group 4 +4, -3, -2, -1, 0. That is for group 8. So when you have this in mind, it helps you when it comes to the calculation. A typical example is the oxidation number, that is the charge for sulfur, is -2. That of oxygen is also -2. So when we start, you understand these things. We also have what we call radicals and their charges. It is very, very difficult to keep the radicals or commit them into memory. That is with their charges. Now, how do we do that? Using this simple takeaway. This is just a takeaway, so you can use it. You can say to yourself, CS equals -2. P -3 all is 1. Once again, CS equals -2. P -3 all is 1. In the sense that most of the radicals, we do forget their charges. So when you pick something like CO3, if you don't know the charge, this one is a guide. The C here denotes that the radical with C contains a charge of -2. Now when we talk about a radical, it is a group of atoms with a common charge. So as you can see from here, it is C and O with a common charge. CrO with a common charge. So that will cater for the C's. Then S here, we have SO4 -2, SO3 -2, S2O3. That is also -2. So that is why I say take away CS equals -2. It works for me, so you can also try that. Then we have P3, PO4 -3. Then when you take the others, please take note, Cl is not part of the C's. Take note of that. Any ion containing Cl is not part of the C that we are talking about. So we also assume that all is 1. Most of the ions which are not here, that is not part of the C's and the S and the P, we assume that they have a charge of 1 if you don't know it. Now let's start. This was just a takeaway. Now in calculating the oxidation number, when it is equated to a charge, that is when you have a charge on it, you equate it to the charge. Without a charge, what you will do is equate to 0. Please, you understand this as we progress. Now let's look at this compound here. We have KMnO4. In the normal calculation, that is, we calculating oxidation number. What we normally do is we expand K, Mn, and O. So that will give us K plus Mn plus 4 here times oxygen. That is equated to 0. Why 0? Because there is no charge over here. Do we know the charge for K? Yes. From the periodic table, K is +1. So that is why we have 1 here. So plus Mn, that is what we are looking for. So 1 plus Mn plus 4 times O. That is what is indicated here. So 4 times minus 2 is equal to 0. And that gave us plus 7. This is the normal method. Now let's look at the trick, which is very, very helpful. Take note of this. We are dealing with oxygen here, which is having a charge of minus 2. In this trick, ignore the minus sign. Once again, in this trick, ignore the minus sign. So that is going to be 2 here times 4. 2 times 4 will give us 8. There is an element here with a charge of 1. So 2, 4, 8 minus 1, and that will give you plus 7. Let me take that again. 2 times 4 minus the charge here, which is 1, and that give us plus 7. Now let's try the trick with more examples. We have ClO3 minus. Now in this example, we have a charge. So when we expand, we have to equate it to minus 1, which is a charge over here, as you can see. So we are expanding. Cl plus 3 into bracket oxygen is equal to the charge, which is minus 1. So 3 times minus 2, which is for oxygen, will give us 6. Minus that will give us plus 5. So that is a normal method of doing the calculation. Now let's look at the trick. As I said, ignore the charge of oxygen. So we go 2 here times 3, 6 minus 1. That is 5. That was quick. Yes, if you know this trick, you'll be fast. 2 times 3, 6 minus 1, and that is what? 5. So when you're asked to name a compound, there's no need going through this stress. Let's take more. We have FeSO4. The underlying element is S here. Now we want to calculate. 2 times 4 here will give us 8. Now the question is, how do we know the charge for Fe, because it wasn't part of the first 20 element? Yes, that is why I gave you a takeaway. I said Cs equals minus 2. So S here, O here is a radical. What is the charge? That is minus 2 here. And as you will see, we don't have any number here, and we don't have this SO4 in a bracket, which means that if this is minus 2, then the charge of Fe is also 2. That is why there is no number crossing. So that is 2 times 4 minus the 2 here, which will give you plus 6. Let me take that again. 2, 4, 8. The charge for this is unknown, but since we know the charge of SO4 to be minus 2, and there's no number crossing to this side, it tells you that the SO4 and the Fe have the same numbers. So that will be 2, 4, 8 minus 2, and that will give you plus 6. Let's take more so that you understand this. In this one, we want to determine the oxidation number for carbon. So with the same trick, fastest way, we go 2 times 3, that is 6 minus 2, and that will give you plus 4. Why? Because we have a number here. Now the question is, how did this number come here? CO3, we know it is a radical. CS, I hope you remember. So the charge for CO3 is minus 2. That is why there's 2 here. There's no number attached to this radical. It tells you that sodium is having a charge of 1. So once again, 2 times 3 minus 2 will give you plus 4. Now let's take this one, BrO3 minus. So we have 2 here times 3, which is 6 minus 1, and that will give you plus 5. I hope you understand. Now let's take a complex one. So we are going to use the trick. We are not going to use the normal approach. Now let's see. As I said, we ignore the charge of oxygen. So 2 times 7, that is 14. Minus 2, because there's a number here, minus 2, and that will give you 12. Since there's 2 attached to Cr, that is chromium, divide the 12 by 2, and that will give you plus 6. Let's take that again. 2 times 7, 14, minus 2 here, that will give you 12. Divided by 2, and that is your sure banker here, plus 6. Now let's move to a more complex one. We have Ba3 to bracket PO4 subscript 2. As I said, if there are numbers crossing, as we can see here, it tells you that this number here came from Ba, and the number here also came from this radical. That is why we have 3 here and a 2 there. Now, with a normal approach, we expand. So that will give us 3Ba as indicated here. Then 2 times P, that is 2P. 4 times O. But because we have a number here, it will be 2 times 4, which is 8 times the O. So 8 times oxygen is equal to 0. How do we get to know the charge of barium? As I said, if there are numbers crossing, it tells you that this number came from Ba, and the 3 here came from that. So that tells you that Ba has a charge of 2. So that is why we inserted 2 here. So 3 times 2 plus 2Pb plus 8 times minus 2, that is for oxygen. So when you divide, at the end you get plus 5. So this is the normal calculation. Now let's look at the trick. Please take note of this point. When you have numbers crossing, as we see here, please ignore the number attached to the radical. Let me repeat that. If there is a number attached to the radical, as you can see here, please ignore this if you want to calculate the oxidation number for the underlined element. So we are ignoring this and we want to do the calculation very quick. So this is 2 times 4, which will give us 8, minus 3, and that will give us 5, as you can see here. So you see, this is very simple to handle. 2 times 4, it is 8 minus 3, and that will give you plus 5, as you can see over here as well. Now let's look at some few. We have ClO4 minus. Now let's do that in the fastest way. 2 times 4, that is 8, minus 1, that will give you plus 7. That is great. You are doing well now. Now let's take the second one. This is N. We are looking for that of nitrogen. So we go 2 times 2, that is 4. Sodium charge 1. So minus 1, and that will give you plus 3. Now let's look at this one too. As I said, if there is a number crossing, it tells you something. Now over here, we have Ca to bracket NO3 subscript 2, meaning that this 2 came from Ca. But over here, we are not seeing any number attached to Ca, which tells you that the radical here is having a charge of 1, and that is what we are going to use. As I said, we don't depend on a number attached to the radical. So let's do the calculation. 2 times 3, that is 6. There's a number here which is not visible, which is 1, because this NO3 has a charge of 1. So that is 2 times 3 minus 1, and that will give you plus 5. Take note of this. We are not using the charge of the calcium. we are using the charge from here because we have a number crossing. Now let's look at the last set. So with this one, I've indicated the 1 as I mentioned earlier on. So we are looking for the oxidation number for nitrogen. Now we go, as I said, we ignore that of the number that is attached to the radical. So from what we have here, you could see that Fe gave 3 to NO3. That is why we have Fe plus 3. So this 3 came here. That is why it is in a bracket. NO3 is having a charge of minus 1. So that will go here. But as I said, we don't write. And that is what we can see here. So this will give you 2 times 3, 6. This is 1. Minus 1, that will give you plus